guys, I hope you're having a great start to your day. Today we are going to continue with chapter 1 and expanding our understanding of matter. So our goal for today is to be able to identify the types of changes that matter undergoes. So by the end of the day today, we should be able to identify the types of changes we have with matter. So we began looking at this yesterday in our lab by conducting 4 different experiments. Today we are going to look at our types of changes a little more closely by investigating how our sugar dissolving was different than our Alka-Seltzer dissolving. How was pulling apart our steel wool different than burning our steel wool? Okay? So we probably noticed some differences as we were conducting these experiments. For instance, when we burned steel wool, okay, probably saw some smoke, felt a little bit of heat, okay? Whereas we did not see these changes when we just pulled apart our steel wool, okay? So visually, we have some different observations occurring, okay? That's because these are going to be 2 types of changes, and that's what we're going to look at today. What are the 2 types of changes that matter undergoes, and how can we tell them apart? For instance, when we pulled apart the steel wool, we didn't change the identity of the substance. It may look a little different, but we still have steel wool. It's the same thing. This is going to be what we call a physical change, okay? Physical changes do not alter the substance at the particle level. So what that means is we have the same stuff chemically, it just looks a little different. And what's cool is we can reverse these through physical means. For instance, if we look at our steel wool, we can easily push that back together. We can easily undo that physical change. If we wanted to look at other examples of physical changes, we could look at dissolving sugar in coffee, because when we dissolve sugar in coffee, we still have the coffee, we still have the sugar, it just looks a little different. But at the particle level, nothing has changed. Being a klutz like myself, I experience the physical change of breaking glasses all the time. So even when you break something like breaking a glass, it just looks a little different, but you still have those glass particles. Nothing changed at the particle level. Or, for example, if we look at making trail mix, the best car ride snack, in my opinion. Again, you're just mixing all these different ingredients together, but at the core, you still have M&Ms, the best part, the raisins, the pretzels, the nuts, all that good stuff, okay? So these are just some examples of physical changes. The list goes on and on. But the main thing we need to remember is when we have a physical change, we are not changing the identity of a substance. The one that always trips people up, that we have the biggest issues with, are phase changes. So if we look at freezing water, if you have a glass of water and you put it in the freezer and it freezes, you still have water. It just changed phase. So all it went from is being a liquid to a solid, but it is still water. Since we didn't change anything at the particle level, this is a physical change. A good way to remember this is physical phase. So any phase change, melting, freezing, boiling, evaporating, these are all phase changes because we still have the same particles. They just look a little different. But what if we can't easily reform the substance we started with after a change, like when we burned steel wool? Reform the substance we started with, we're going to call this a chemical change. So in a chemical change, we produce a new substance. So that means we have changes at the particle level. Okay, we're ending with something different than what we started off with. This is the type of change that we're going to look at primarily throughout the year. So if we have changes at the particle level, that means our particles are being rearranged. If we look at this example, we have hydrogen peroxide, which is just going to be H2O2. So we can see H2 and our O2 molecules bonded together, our hydrogens and our oxygens. Okay? When our chemical reaction happens, our atoms rearrange and we form water and oxygen. Okay? So we can see now that our particles are grouped differently than what we started off with. This is a sign of a chemical change. What we start off with, we're going to call this our reactant. So those are particles before the change. Once the change occurs and our particles are rearranged to form a new substance, we're going to call that the product. Okay, so the products are always on the right-hand side of our reaction. Some examples of chemical reactions or chemical changes that we are familiar with include burning. That's the one we saw with our steel wool. Okay, we formed a new substance when we burned that steel wool. We had changes at the particle level. Think about baking cakes, cupcakes, muffins. You can't get your ingredients back from that cake easily. Okay, you had a chemical change take place. Same with rusting. If you leave your bike outside and gets all rusty, you have changes at the particle level. Those particles are rearranging to form something new. You can't just unrust your bike. Right. But how can we tell if we actually have a chemical change? We are going to be looking for one of four main indicators. Another sign of a chemical change is when we have a change in energy. So the energy can take place in the form of heat, light, or sound. So if we look at this reaction, I'm going to put my glasses on first. We can see that light is being given off, so energy is being released, so we know this is a chemical change. Second indicator of a chemical change is the formation of a gas. And we typically see that formation of a gas in the form of bubbles. So when you see bubbles start forming, that is a good indicator that we have formed a gas and we have a chemical change. We also saw this in our lab when we dissolved the Alka-Seltzer in water. It was that gas that made that lid pop off. The one caveat we need to make with the formation of a gas is that it can't come from boiling, because we know boiling is a physical change. So if we have production of a gas from boiling, that's a physical change. But if we're not boiling anything and we still see those bubbles, we see that gas formation, then it's a chemical change. Another sign of a chemical change is going to be when we take two liquids and when we add them together, two liquids, we form a solid. So see that fogginess or that cloudiness that we have there? That's going to be the formation of a solid. So our third form of or indicator of a chemical change is when I take two liquids and I combine them, I form a solid. And that's going to be what we call the formation of a precipitate. We call that solid a precipitate. Another indicator of a chemical change is color change. So here we have a blue solution. When I add my HCl, we're going to see that my solution starts to turn yellow. Okay, so I started out with a blue solution. I added clear HCl, and my solution turned yellow. Okay, so I had two completely different colored solutions that spontaneously turned yellow. That is a sign of a chemical change. So, as a summary, if we see any one of these four indicators, we most likely have a chemical change. So if we see a change in energy, whether that be in the form of heat, sound, light, any change of energy, that's a sign we had a chemical change. Production of a gas, that is not from boiling. So we mix two substances together and we see bubbles, that is a good sign that we had a chemical change occur. Also, the formation of a precipitate. So that's when we mix two liquids together and we form a solid. So we take two liquids and we form a solid. And then the last one is spontaneous color change. So that's when you're taking two substances, mixing them together, and you get a totally different color than what you started off with. So if you see any one of these 4 indicators, that is a good sign that you had a chemical change take place. Alrighty, so now we've talked about different types of changes, or physical and chemical changes. That is going to be our verb. Okay? We can also talk about chemical and physical properties as an adjective, and we're going to use those properties to describe a substance. Okay, so starting off with physical properties. These guys can be observed or measured without changing the identity of a substance. Okay? So some examples of these will include color, the temperature a substance boils, melts, or freezes at, odor, magnetism, ability to dissolve, the color, the size, etc. So if we look at Kool-Aid, for instance, some physical properties of this Kool-Aid would be that it's red, that it smells like watermelon, it dissolves in water, how large of glass of Kool-Aid I have, and then I could also talk about that ice, that our ice freezes or it melts at 0 degrees Celsius. So that would be another physical property. So a lot of times when you compliment someone on like their clothes or shirt, you compliment the color, how it looks. Those are all physical properties. Okay. So you've already been noticing these throughout your daily life. You can further break down physical properties into 2 types. We have intensive properties and extensive properties. So intensive physical properties, these do not depend on the amount of a substance. And we can use these to ID or identify what a substance is. So if we look at some examples, we have boiling point, melting point, and freezing point. Those are all intensive physical properties because no matter how much water you have, it is always going to freeze at 0 degrees Celsius. Same thing with magnetism and ability to dissolve. No matter how much Kool-Aid you have, it's always going to be able to dissolve in water. A good way to recognize these is that intensive has an I in it and ID has an I. So that'll be a good way to remember that intensive properties can be used to ID a substance because it doesn't matter how much we have in front of us. Those are always going to be the same. On the other hand, we have extensive properties. So extensive physical properties, these do depend on the amount that we have. This would be like mass and volume. We cannot use these to identify substances because it really doesn't tell us anything about what we have in front of us. If I say that I have a liquid with a volume of 10 milliliters, that doesn't tell you anything about that liquid other than I have 10 milliliters of it. So we cannot use extensive properties to identify substances because it's only dependent on the amount that you have in front of us. And then our last type of property we are going to look at are chemical properties. So these guys describe how a substance can change chemically. So here we're looking at the particle level. How can we change those particles? So some examples here might be reactivity. What do they react with? Flammability. Does it catch on fire? And pH. And that's going to be our acids and bases. Okay, so these are all chemically because it's talking about how we can change the identity of a substance. Okay. About physical and chemical changes. Go out and see how many of these you can find in your everyday life. Okay, so around your house, when you're at school, how many physical and chemical changes can you find? Do a fun little scavenger hunt. Bananas ripening, boom, chemical change. Water boiling, boom, physical change. Cooking toast, boom, chemical change.